250 volt wheels. You know what? Let's change topics. That's a really great starting point. So I'm going to cover it on two sides. The voltage equation. Do you have something to say, Sensei?
No, I'm soaking it in. Go ahead.
Okay. So the voltage equation, I was playing with this earlier actually on a spreadsheet. Maybe I'll share it once I get it finished out. But I had this question in my mind because for years I've posed to electrical engineers, how do you calculate the relationship between battery current and phase current? I know we're talking about voltage, we'll get there.
Mm-hmm.
So the thing is, the amount of amps coming from your battery is not the same number of amps that are circulating in your motor. They're different values. And the thing is that how do they disassociate from each other and why? And so you could say that, like, for example, at low speed, it might only take 5 amps from your battery to get 150 amps circulating in your motor, okay? And so this relies on principles of inductance. This delves into the side of field weakening, and one of the electrical engineers explained the concept like this. So if you take into account field weakening, what essentially is happening is it's storing a little bit of extra energy between the magnets in your motor. And what this feels like is that you have an instantaneous buffer for positive and negative torque. And it just, you can feel it. Like everybody that I've told how to configure this setting, they all are like, whoa, that's so smooth. Like it performs so much better. I'm like, yep, this is just the beginning. So, field weakening is what I call like a 1+1, right? The earliest unicycles, if you've ever heard of a rock wheel, this unicycle was notorious for failing from back EMF. Back EMF is if you rotate a motor, not including plugging it in, you just rotate a motor, energy is going to come out. That's back EMF. Back EMF is managed by the process of field weakening. So you could say that field weakening is a control system that allows you to manage the energy that comes back from your motor. Mm-hmm. Now, why is this important? Imagine you're doing a jump and your motor's spinning up and you hit the ground. Well, all of a sudden, you're going to get a massive electrical spike. And this electrical spike has to be absorbed by your motor controller. It can do several things. It can try and send it to the battery. It can't just absorb it right into the limits of the MOSFETs. There's different ways it can deal with this equation. The earliest unicycles like Rockwheel, they would straight up fry. Like very interesting model, very interesting history in Rockwheel, but they were known as the most unreliable product line because they had no management for back EMF, and the motors they chose created a lot of it. So on to the concept of voltage. That lays the groundwork for looking at it and saying voltage is subjective, okay? It multiplies what you're doing with your current, but it's not the only factor. So here's the thing. If you compare a 100 volt wheel versus a 134 volt wheel, and if you take the wattage and you do the division, you figure out how many amps you have to have the same wattage on each voltage. You got two different systems, and you have equal wattage but different voltages. That will mean one will have more amps and one will have less amps. Okay. Now, if you're using 134 volts, it means the voltage in your motor will ripple more. And this means that you will have problems with keeping that under control on the controller side. So that means your electronics, they get more exponentially more expensive the higher voltage you go. It's not quite exponential, but it's quite a steep curve. So I agree with you in the sense that 100 volt technology is not even close to maturity. The 100 volt systems that come out of e-bikes and other things, they are really good. Like there's a VESC that came out recently. It's 100 volts and it can do about 500 amps and it's like this big. Like it is smaller than any electric unicycle controller and it is really constant. It can do more than any unicycle controller as well. So, I'm looking at these systems and I'm saying, what is the right choice? I'm trying to thread my needle through a massive, just massive number of engineering, design, electrical, management, plan choices to bring this thing to life, right? Mm-hmm. And what is the right voltage? So I think that the main thing that defines the voltage I seek in my products is it's a two-sided thing. You have the minimum usable voltage for what you need to do, and you have the safe voltage for human beings. Okay, and these are not the same number. Okay, so minimum voltage, you might be able to get a pretty decent unicycle at 100 volts. But if you jump to like say 134 volts, you get a pretty decent power increase, and the cost of components is pretty good. But what you start seeing is that you go beyond that, and you start getting to risk of, you touch two things and you get a heart attack level of shock. Like it's so dangerous that I, as the creator of it, would be at risk to build the thing. Okay, much less all of the people who have to test it and ride it. And if they ever ride through a puddle and the wire becomes abraded and they get shorted out, what is the liability of that?
Dude, that is so, see, people don't think of that stuff. Yeah, see, that, I'm glad you brought that up. Even with EV cars, I love watching all that stuff. And I was watching these dudes, they open one up and they're like, you got to be careful. You touch the wrong thing, you get a nasty zap. Oh, that's from when talking about the high voltage wheels. Yeah, dude. Yeah, we don't.
No kidding, dude. Seriously. Oh man, yeah, I died from a tire change. How about you?
I think I fell back.
Imagine being up there in heaven. Yeah, that was not the right thing to do. It's a pretty significant thing when you're approaching the voltages of electric cars, because these 250, 300 volt concepts, yeah, they're technologically possible. But have you seen, like, people have a pole ready to pull the guy off if he accidentally shorts it out and is like, you gotta, it's a two-person team to take one of these things apart. Like, can you imagine having your buddy watch your back while you take your unicycle apart just because you might get electrocuted to death? Like, are you serious? Like, we can do so much more with current without the risk. See, I could have a 1,000 amp system and you could touch it and it'd be fine at 100 volts. You wouldn't even feel it, right? Mm-hmm. But if you try to do 1,000 volts at 100 amps, it's gonna kill you. So, I mean, realistically, I think that we don't need 250 volts. We don't even need 150 volts. Like, around 134 is already like way high enough to optimize on the other side of the equation. We can optimize for current, we can optimize control theory, we can optimize motor design, we can optimize, the wires, we can optimize the battery design, we can optimize how the batteries are connected. All of these things have nothing to do with the actual end voltage, but they do equate to a total higher power. So it's like, you don't have to increase the volts to get more power. This is 100% myth. And in fact,
dude, I was thinking about that a long time ago. I was like, man, they keep jumping up in voltage, but I'm like, man, you had the EXN that was 100 volt, was doing 54 miles an hour. And I was saying, if you put an upgraded controller and just tinker around with it, what else could this thing do?
But that's a great point.
All right, one second. Let's answer this question here for Stan, because he has something about regenerative braking, a possibility for EUCs. Okay,
so in reality, EUCs already use regenerative braking. They have since the very first model. In fact, there was maybe one model of EUC ever produced without regenerative braking. It was by IPS, a now defunct unicycle company. And when you brake, it was super soft. Like the braking was much softer than the acceleration. They gave it no brakes, almost no brakes. And so that did not have regen, but all other electric unicycles nowadays have regen from the get-go. How efficient that regen is, that's a new question. See, there are more efficient ways to recover that energy than what is being implemented now. But I mean, that is a engineering rabbit hole that's too deep for this conversation. But the short answer is they already have it. The long answer is it could be better.
So. Right. I know, like with cars, they have different levels of it and stuff like that. So maybe they could, they're really not.
Actually, mechanical disc braking is a possibility in the future of unicycles, I think. I'm not 100% sure it's worth it, but if I can't crank up the amount of braking force on the electromagnetic motor, if the motor can't provide enough braking force, then the end game would eventually be to have a physical brake. I haven't seen if that's really the upper limit, because it's like every time you build a more powerful unicycle, people just keep figuring out ways to overpower it. So it's like, I don't know how much power you really need before it's essentially impossible to overpower it. That's
right. Right. No, I get it. I mean, right now, any of the unicycles, if you get on that thing hard enough, depending on what surface you're on, you can overpower that thing. Any of them, really. Tail lights are a little bit. I know, like with the Mini when it first came out, it was just blinking steady. You know what I mean? It was that type of thing. And some of them,
Yeah, my buddy was talking about that. He's got a Commander Mini. He's like, can we make the LED turn off? And I'm like, if you want to open it up and cut the wire, yeah.
Yeah, right. Yeah, put a switch on
Right.
it, splice the wire and put a switch on it.
Yeah, that's a classic example of poorly parameterized accessories. Like in my vision of this unicycle, I'm working on a battery management system that does two things. It manages the batteries and it manages your accessories. So I've got 4 universal kind of controller outlets where I can control fans and lights, and I've got special connectors for addressable LEDs and stuff like that. But the result of my system is that my battery management system, everything will be parameterized in firmware.
Gotcha.
Everything, and I mean everything, and that's quite a break from how most battery management systems are designed. Most battery management systems are based on an integrated chip that has a pre-programmed logic for how to deal with all the cells. This has the limitation that they're not typically designed to work in parallel or series like unicycle packs. And it can introduce instabilities, and overall, they feel like a retrofit solution. That's why if you look up split pack battery management systems, you'll find pretty much only unicycles using them, where there's very, very few other industries. Because my entire BMS and accessory control system is all parameterized in firmware is all open source, people would literally be able to go in and write any kind of LED protocol they want for any kind of LED pad, any kind of LED strip, And so this would basically allow people to just, this is a Lego factor, right? You can go online and find a lot of different kinds of LED strips, and my accessory controller supports majority of them. The poor implementation of accessories is like, on one hand, I'm saying I'm going to make it open source, but on the other hand, I have a high standard. I'm not going to make something that doesn't work. It's obvious to me. It's like Americans have expectations. I'm just going to talk to a few of them. They will immediately tell me if this is cool or not. It asked a single American if the taillight being on permanently was the right design decision. What do you think they're going to say? So it's like they don't ask the community, and that's a big thing that I've been thinking about. That thing hit about 55 miles per hour, and I don't know if you know the original Sherman Max. It did not go that fast. So it's like,
wow.
It's like, this is field weakening on the stock battery pack, and so maybe I should go a little bit into detail about the VESC thing, because I'm sure a lot of you guys have no idea what I'm talking about.
Yeah, but please touch on that.
All right. And in the early generation of unicycles, I spent time with the inventors of it, and I spent time watching them write patents for it. I even assisted one of the inventors in writing his patent. So I've actually got kind of a really insider take on how these people think of patenting, and how they think of protecting their ideas. And my perspective of it over the years has shifted to the polar opposite. I am heavily interested in the open source side, because the open source side has helped me so much. I wouldn't be able to build all the custom unicycles with the custom balancing algorithms if I hadn't had this open source VESC system. And so, but the contributions of these people, Mitch Lustig, Benjamin Vader, and many of the other creators who've committed hundreds or thousands of lines of code into this thing. The VESC code base is massive. Like I tried to put the entire VESC code base. I tried to figure out how big it was. And it's like thousands and thousands. It's like I think it's like 100,000 lines of code or something. It's really huge.
Massive.
A lot of that stuff is support because it's made for things more than unicycles. And that's one of the factors that I'm really interested in, is that I'd like to tailor it, but I don't even know if I'll have to. The trending of VESC has been that they have been cutting out unnecessary stuff, and they've been separating it out into a package system. So this is so revolutionary. I know that it's kind of like far out there for the unicycle community to imagine, but think of it like this. If the computer inside your unicycle can run an operating system, that operating system is called VESC. And VESC has everything that it needs to know how to control a motor and listen to a gyroscope and an accelerometer, and have an entire scripting engine built into it, so you can program it very easily. Like that's what VESC is. And what they're going to do with it is stuff like the unicycle side and the one wheel specific packages and all these things. You can install them like apps on your smartphone. Like you can install this. You can install the unicycle profile that you want, and that's the future of it. It's like, these VESC control systems are mind-blowingly flexible. Like I can't See that toaster oven behind me?
Yeah,
I don't know if
dude.
you can see the toaster oven behind me, but
I see it.
that's a VESC powered toaster oven. Okay.
That's awesome, dude.
That I just gotta pull this over here.
That is awesome.
This is a VESC powered toaster oven because I wanted a highly precise toaster oven that would allow me to control the exact temperature.
That's crazy.
And
in a good way.
I didn't want to go buying a temperature controlled oven because I thought, you know, that's really expensive when I have a regular oven and a VESC. And so,
dude, that shows you the amount of control that you can have if you pop that thing in a unit. You see what I mean? Just that little, that's nuts.
VESCception. I don't know what that means.
I think I like that though. VESCception.
Well, a VESCception would be if I'm using my VESC welder to weld batteries that are controlled by a VESC BMS, which is then connected to a VESC motor controller. That's VESCception. So the crazy thing is that after I started messing with the toaster oven, I know it's a bit of a tangent, but hear me out. After I started messing with the toaster oven, I used a very similar algorithm that I used to control my unicycle, except that it runs in slow motion. You know, it's roughly like 100 times slower of a system than a balancing system. You know, on a unicycle, it's just like constantly correcting around 1,000 hertz. So you could say 1,000 times, I think that's per second. Yeah, 1,000 times per second, it's recalculating the position and sending the command to the motor, right? And so on a toaster oven, you only need like 10, right? So it's like 10 times a second. I can watch the values change, and I can watch how these control systems behave without it moving so fast. It's faster than the human eye. And so I've actually used this as a test bed to develop some of the more complicated algorithms that I will then later put into a unicycle. You know, it's not 100% a perfect test bed, but in terms of, you know, something that's not going to spin up and zoom around the room if I write one wrong line of code, it is much better. So,
yeah. Dude, I want to just say something on, just go back a quick second. We had spoke on this, I think, yesterday, when you said you want to leave it open source. And if you go back and you look at Trevor Blackwell, when he created the unicycle, right? And then he basically left it open source. And then Paul Woods came in, I think it was the SBU. And when they met, it was like total respect. Trevor looked at it as like, man, he's like, yours is better than mine. You mind if I give it a ride? You know, it was like, it was so cool. It was like no competition. He left it open. And Paul took it up a step higher than what he did, you know? So it was really cool to see that. And I think leaving stuff open source like that could actually just advance things a lot quicker, you know?
Well, I mean, it's the, like, I talk to a lot of people developing custom algorithms for these things, and the amount of freedom they have when it's all open source, like,
everything will come together, man. And I'd love to see a VESC with race tuning, jump tuning, even pedal sliding tuning.
Yes, sirree. It's possible. All things. It's just, you know, in fact, you can do it right now. You have a unicycle with a dead controller, call me up. I'll tell you which VESC to put in there, you know, and I can direct you to my Discord server where I share a bunch of different configurations for different unicycles I built. I've got a configuration for a Sherman Max, for a Galway Monster, M10-3 is very popular, although I personally don't recommend it because it's one of the most challenging to tune of all of the, you know, if you start with a bigger unicycle, it's going to actually be easier to tune because you have more margin to deal with. When it's so small, the power is so small, you're like fighting a very small line to get that balanced state. But when you're dealing with a much more powerful system, you can have more error and it can still just, you know, use the power, and you can ride it and feel like the smaller differences. Whereas on the M10-3, you can't even ride it before you have to get the settings so close. So it's like, I recommend you pick a unicycle with a, you know, a blown motor controller. Pick something that is like, either you're gonna have to build your own battery pack or run without a BMS, or use something like a Gotway that has a standalone BMS system. So that's one of the main bottlenecks, is that if you've got a Sherman controller or a Kingston controller, their battery management system, like the central part of it that does the charge control, is baked into the motor controller. So essentially, prevents you from direct swapping to a VESC because there's no way to replace the charge controlling electronics.
Oh, I see.
Now, the battery management system I'm working on could hypothetically support, other packs like Sherman packs, for example. I could use my master module with a Sherman battery pack. It's a theory I've had. I haven't tried it yet, but it's something to consider as like an aftermarket master module, so you can connect to an existing pack design. And like, let's say you want to use your Sherman packs in your Gotway unicycle. Well, this would allow you to do that safely and have full charge protection. And so that's another like Lego factor, is that the battery management system and the way that it's like tangled up in the motor controller design and the way many of these unicycler manufacturers are doing it is, it's bad for two reasons. It means that if your charge control electronics fail, it takes down the motor controller with it, and vice versa. So it's extra cost, and it's too many things in one space, and it's kind of easy from an assembly standpoint because you only have to assemble one circuit board, but it's bad from a repair standpoint because I've seen this happen where a perfectly good Sherman controller lost its charge control electronics and we can't use it anymore. It's useless.
Right.
So it's like, okay, so now we have $350 of electronics attached to $5 of dead MOSFET. That was a great financial decision.
Yeah, that's crazy, man. But these are things, again, this is what I do. We gotta work toward helping you get this made, man. We need it. We need it.
Thanks, man. I appreciate the help. 0% risk. I'm going to tell you outright, I've already researched the risk of magnesium after molding, and it's essentially impossible to light. Like, even with the battery fire, it's pretty much impossible to light it. I don't think it's that much of a weight saving feature either. I think it's a little bit, but given the suspension system and the structure of it, and most of the mass being in like the rim and the motor core, and in the battery pack and in the suspension linkage sliders, the majority of the mass isn't in the shell components. You could use, there's a lot of options. You could use just pure aluminum and it'd be very, very close to the same weight. And so, I mean, maybe it's stronger. And I think that what they're doing is very interesting. They're making a very mature production move. And what I mean by that is that they've developed enough products and their production rate is, or their release rate of new products is slow enough that they can invest in stuff like magnesium molds. Because if you go out and try and mold something out of magnesium, it is not only a challenging metallurgical process, but it's also expensive. The molds themselves are very expensive, and the parts that are produced from those molds. And so magnesium or carbon fiber or aluminum or fiberglass or polycarbonate or any of the above, every single one has benefits and drawbacks. Personally, my favorite combination of materials is ABS, fiberglass, and polycarbonate in a sandwich.
There you go. I was always thinking why they never use like a polymer, like plastic.
Well, my idea isn't straight up polymer. It's actually based on vacuum forming. So vacuum forming is a very old and simple technology for making large parts, which is ideal for unicycle body components. I haven't decided on this yet, but I've been researching and I've had a few parts made by vacuum forming in the past. And the last parts I had made were some enclosures for the electric skateboard, the airless, and the enclosures had actually two materials. So it started out as a flat sheet of plastic, and there was a sheet of polycarbonate and a sheet of ABS, and they were laminated together in the production process. It starts out like a meter square sheet of two plastics in distinct layers. And so this process, you can then heat up that sheet of plastic and suck it down on top of your mold and thermally form it with vacuum to make it the shape of your mold. It's very cheap, it's very fast, and you just have to cut out, around the mold with a router when you're done, and it's done. So I'm thinking to modify this process a little bit, and it's in research right now. But the idea is that to take those two sheets of plastic and put a grid of fiberglass in between. So when those two pieces are merged in the manufacturing stage, that you have a something that all these strings that can pull when it forms down to the mold. And so basically, inside the plastic, inside two layers of plastic, you could have all this fiberglass, and the fiberglass should be held in place by the plastic, and the plastic should, hold the fiberglass in place, vice versa.
So your fiberglass is your core. Like the fiberglass would be your core.
The fiberglass is the core, and the plastic is the outside. Yeah, instead of using fiberglass and epoxy, it's actually And so these things are like, this is non-trivial. Like to produce this, I probably have to order at least 100, square meter, sheets of this thing minimum. The manufacturing minimums on custom materials, it depends on who you're going with, but it could be much more than that. And where I could find that material already existing if it's out there somewhere. And so this is just one idea. There's a lot of ways to produce unicycle bodies, and my thought is, A, I want to use the best of the ideas I see out there. B, I want to supplement it with some other ideas that I have that work really well with what's available in the US or available in my existing, supplier, notebook of people who I know to do these things. So.
Right. Good stuff, everybody.
Could you shave a lynx to make a fire and wilderness survival situation? Probably not, but you could short the battery and make quite a little spark going there.
Yeah, right. Go fire.
Another survival situation that just about happened to me the other day. Car ran out of battery, and fortunately somebody came by to jump us. But I remembered a friend of mine, this guy Will, friend of mine, he was telling me that yeah, you can 100% jumpstart a car with a 100-volt battery. So if you've got a pocket knife, you can scrape the silicone off the wires on your 100-volt battery and jump your car. 100% works.
What?
But I will not vouch that it won't blow electronics in modern cars, but it is,
it's possible.
Theoretically, to 12 volt is going to short the potential of the lithium, and that'll be really bad for the lithium for as long as you're doing that. But if you pull it off fast enough, everything should be fine. Otherwise, you might have a spare fire starter happening immediately. So, but yeah, let's see, what's the next comment here?
Is it possible, more likely, a spark if it ran into the ground? I guess he's just talking about the magnesium alloy there.
Oh yeah, it's extremely, extremely unlikely. I think untreated magnesium can be lit with lithium fire, but once it's molded and stuff, it's, as far as I'm aware, it's not going to burn any more than aluminum or stainless steel or anything else.
Okay, we're going to take another one about the magnesium.
Yeah, that's pure magnesium. It's different when it's actually like in the molding process, they introduce agents to make it non-volatile. Otherwise, it literally blow up their molds. There's like a whole metallurgy behind it. It's not my specialty. I only have just, talked to these manufacturers a few times about it. The question is, how can you save weight, and is there a better battery? The short answer is that at this exact moment, there isn't a super lightweight battery that's significantly better than the 50S. 50S is the best all around. However, if you want something that is extremely light and has the same kick as your full-size battery pack, there's a new cell coming out called the MollyCell P50B. This cell has 5,000 watt hours and a 100 amp discharge.
Wow.
I don't know if that makes sense, but like the previous top discharge cell was 45.
Yeah.
Okay, so this is more than doubling the highest cell we've ever produced, which is already the highest on the market. So if you take this cell that doubles the output of the best existing cell today, which is this new P50B, should be out pretty soon, or it's out already. I don't know. It's very close. It's very, very, very close. They've been talking about it for months now. So anyways, the P50B is by MollyCell, and yeah, that thing is going to change the game for lightweight performance, because it was literally designed for high performance EVs. Like, they didn't say it in the sales brochure, but they should have said unicycle batteries. Straight up is the best battery you could put in a unicycle when it comes out. It'll have the capacity and it'll have the kick. So, I mean, imagine a 50S with 3 times the power delivery. That's what the best of the 50B is.
That's crazy.
So that will allow you to make essentially a 1 or 2P pack. And if your voltage is really high, you won't be able to get so like 167 volts, you'll be able to make a 1P pack. So basically one series of cells, and it'll have enough kick to run a 167 volt wheel. And that'll change the minimum weight by a lot. And if you do like a 2P pack, it would be more power than almost any battery on the market. Talking 2 in parallel. Most like a Sherman S. No, let's say regular Sherman has 5 18650s in parallel, and a Sherman Max has 5, 21.7, hundreds in parallel. Just to give you an idea how big these packs are, right? So, or wait, no, it's 10 in parallel because it's 5 on each side. Anyways, yeah. So a pack that is, if my mental math is right, a pack that is a fifth of the size. You could make a pack the fifth of the size of the Sherman Max and have more power than the original one did. That's the power of these cells.
And I was saying that before too. It's like, I think in order for the EUCs to make a significant jump, they're going to have to do something with battery tech. And you just hit the nail right on the head with that. So
there's the flip side of it too. There's another cell called the F60 by Vapcell, and it's 6,000 watt hours, and it's can put out a decent amount of current, but you're going to need a large pack, like a Monster Pro size pack or whatever, to actually, you know, utilize that cell, because it's not high discharge, but it would be extremely long range.
Right.
So, and it's also, the cool thing about this particular cell, you get like 600 cycles, and it doesn't break down very much. Like, it'll have more capacity than anything on the market at 600 cycles, after 600 cycles, including the P50B that I just talked about.
Wow.
So there's some very interesting cells out there for capacity and performance, and it's about to like go like this into the polarizations of like super capacity and super performance.
Hey, just another quick shout out. Devo, thanks for coming in. Stan, welcome to the chat. Amped Electric Games. And here is a really good question. I want to take a question here because I think this is, we had spoke a little about this before. And he says, I would love to see an open source EUC give us the parts to Lego them together, our own. I love to see a platform to roll your own. So we kind of touched on that a little bit. So what are your thoughts on that?
Well, I have a group for people who are interested in doing such a thing. And basically it's called the, I call it the VESC EUC mods group. And that has the term VESC in the title. VESC is a open source control system for electric self-balancing devices. It can be used for other things, but you know, mainly VESC is an open source system. So this is one factor that I'm hugely interested in. Something that I'd like to see is that a majority or all of the firmware that my device runs on is actually open source, so that if anybody has a concern about how it actually operates, they can peek under the hood and see how it, you know, really ticks. Mm-hmm. The idea here is that you know, it wouldn't also be, you know, a lot of the Gotway, I say Gotway, I won't call them anything else. A lot of the Gotway firmware, they release these days. They've got like multiple versions. They got race mode, they got jumping mode, or whatever, you know, and it's starting to break the pattern. And this is something that we've seen in the VESC industry for a while now. That especially in the one wheel space, they're hugely involved with VESC, and there's a massive number of people adopting it over there. Because in their space, there is no competition. There is one company making these products, the one wheel shaped product. Right. And so with that lack of competition, there's very poor quality. Well, I shouldn't say poor quality. The one wheels are actually high quality. It's just the spec is so low and the price is so high. It's not a good combination. Gotcha.
And so you've also worked with one wheels. Is that correct?
Yeah, I work on them. I've never worked with a company, but I do mod kits and things for them.
Nice.
Like right now, we're producing a wedge-shaped enclosure that allows you to put more battery in your stock XR. But yeah, that's like kind of a way I feel like is a great way to like warm up the production line and get a feel for how exactly does it work to produce something in the US and sell it here. Mm-hmm. You know, there's a Lego factor to it, but there's also specific things that are. I'm trying to decide how much to like fully integrate a concept into one unicycle versus making it like little modules that could be more reutilizable. This is a line I'm going to constantly have to redraw until we get through the production process, because it's something that it's like, you know, you might think, oh, if I make a battery that's this shape, it's going to work. I can imagine it working in all these different places. But then you get to unicycle number 2 and it's like, well, realistically, it'd be this version of the unicycle with a 24-inch tire needs 3 times the battery, not 2 times the battery, so I have to make a new pack design, right? You know, those are problems I'm gearing up to challenge, gearing up to deal with, right?
We'll go back to how we were saying before, how they're just coming out like every month and a half. And it's like, are they really innovating anything? Because sometimes they're taking boards from previous machines, putting them in this, you know what I mean? There's just like mixing and matching. There's really no big jump in what they're doing.
I mean, mixing and matching makes sense. right? So it's like if I came out with a 20-inch unicycle like my renders, you know, in my head, I've already pre-planned the mix and match of battery packs with a 24-inch model and controller mixing and matching and the battery management system mixing and matching. And in my head, I'm thinking, if I'm going to make one product, I'm making the basis to build all of them. To do a production line, you do need the ability to mix and match, but that can't be the basis of innovation. That's the basis of just fleshing out your production line or your product line, right?
Yeah.
Like, and you can't do this, just Rubik's Cube the thing and sell it again. Like,
that's
your customers are going to catch on.
That's what I'm trying to say. And that's what's happening. And it's like, okay, I get it. But it's like, why should I take, I'm already paying $4,000 for a wheel. And then not even 3 months later, another $4,000 wheels coming out. And the changes are so minute. I should just hold on to what I have. But the way people are, they always want the newest, shiniest thing, thinking it's better. So, you know, they're playing on people's senses, man.
It's also like noise, because a friend of mine was debating with me. He'd come over every day almost and talk to me about unicycles and say, oh, should I get the Lynx? Should I get the Master? Should I get and he was like, yeah, you know who you are. You're watching this right now. He came over. He came over and we were talking about this, and I said, you need to pay attention to the total testedness of this thing.
That Koenigsegg, man, the freaking motor, dude, is crazy, and it's so effing small too.
Yeah, I've seen that.
Like, it's crazy.
Well, there's two sides of it, right? There's the power density of that motor, but they're also like leveraging it to the max to get those numbers. And if you leveraged a regular unicycle motor to get the max of what it was capable of, 8,000 watts wouldn't be the number on the outside. Okay, like I assure you, I can get more than 8,000 watts out of that Lynx motor if I put a VESC on it.
Oh, I believe you 100%. Well, I always said that too. It's like, even if you go back to the Nikola motor, right? I always say the Nikola and the Tesla V2 had the same motor and just different controller.
No. The Nikola and the Tesla don't, but I get the confusion. They have one had a C28. The Tesla had the C28 and the Nikola had the C30. And
I never knew that. I thought they were both like 2,000 watt motors, or they said 1,900 watt hour motors.
Right. But yeah, the width of the magnets is different by 2.
I got you now. I'm glad. Thanks for clearing up.
They're very close. Yeah, they're close.
Yeah.
But I mean,
the output of the motors was much more. You could get more power out of those motors. Just like when
If you compare, exactly. If you compare what they did for several generations, they didn't change a thing inside. They just changed the number on the outside. It was like, where's the more power coming from? Well, it's because your controller is putting more power through it.
That's the thing, man. That is the thing. I always say that those motors, man, they have way more power than what they're telling you. They just allot a certain bit for that wheel, and then they'll use the same motor and another wheel, put a different controller and up the power.